Thank you, Joe. So Monty is going to speak to a few slides from here.
Sure, and yeah, and let's just take it from here. So the figure that we put here is an attempt to illustrate the whole transportation episode from origin to destination. As we go through the process, we see what kind of operation strategies and data for safety that we can get. And then on the bottom is what the intervention strategies that could be used to improve safety. So if we look at the origin over here, we have the traveler. We can get data about traveler characteristics. Then as a traveler is making some travel modes, whether they are using transit or vehicles or so on, we get crowdsourcing data. And that's an opportunity to intervene with some driver information that might affect the traveler decision on choosing the different modes. And then as the travelers take different routes, in this case, when they are driving, then we could get data from probe vehicles. And then we could also have the opportunity to do some interventions through trip management um, strategies or like apps and so on. Then we look at the microscopic behavior as the travelers are making those decisions, car following, lane changing, and so on. We could get data through connected vehicles, and then we could intervene through driver warning and so on so that we can prevent opportunities for crashes and so on. And then we go through traffic lights. So again, we could have high resolution data. And then we could intervene through traffic control strategies. And then when we look at the macroscopic flow, we can use computer vision and video analytics and so on. So we can get, like, for example, safety surrogate measures and so on. And that also gives the opportunity to do some incident management until the traveler makes it, hopefully, safely to the destination. Next slide, please, Filmo. So we looked at the literature. That was the first step, and basically we saw several categories in the latest literature. So examples of operational strategies for the proactive safety in this case, there were some research efforts looking at reducing traffic conflicts, reducing crashes by managing vehicle movement, and so on. There is some work about harmonizing speed, and that has been going on for a while, actually. But then the idea is to manage speed differentials within and between lanes to reduce crash risk. And then there is efficiently managing incidents. So once you have an incident, then you want to reduce the opportunity for or the exposure to have secondary crashes. And then you can also improve post-crash care. Then there is the enhancing road user awareness to help prevent crashes by alerting road users to safety-related events. Work zone in itself, of course, that's also a whole area where people do research and improvement, technology-related improvement, like queue safety, for example, detecting and alerting driver to slow traffic ahead. There is monitoring traffic in real time to enable quick responses to congestion and safety hazard. And then finally, making data-driven decisions to help identify high-risk area and optimize safety interventions. Next slide. And then we also looked at the data sources. So what kind of data can we get with all of this? One of the major data sources was original equipment manufacturer cloud data. Now, and there were several companies collecting this kind of data and selling it to some aftermarket sellers and some of the companies and so on. There is also the probe data and the user supplied or crowdsourced data. And then the computer vision from the area of machine learning and computer science in general have been used a lot, including YOLO, several of those new algorithms too. And then there was the smart cities and the Internet of Things opportunities to collect better data and more ubiquitous data. There are some data management platform, some of the vendors who are selling some apps add-on apps and so on with the services that they are providing. And then there are some data sharing applications and um, that also is very helpful, whether it's real-time data sharing or some of the efforts that we're looking at. How can a person go and identify a problem and then share whatever that they find through servers to the other team members and so on. And then there's also improvement in methods and frameworks for crash prediction. Again, with the enhancement in technology and with all the IoT and other methods, there were some development in algorithms and some development in the technology itself to improve prediction. And that's an area where you got the integration of technology with the well-known traffic flow theory and so on. And also machine learning got part of this for crash risk prediction and secondary crash prediction. And then some researchers did some dashboards and decision support tools that have been used in some jurisdictions. And then there were some evolving metrics. We have seen the surrogate safety measures from a long time ago, but the enhancement in the technology allowed for faster processing and therefore the ability to come up with new surrogate safety measures as well. Next slide. Integrated safety and operation framework. There were some effort using data with business intelligence tools, using real-time data in integrated safety and operation framework itself, and then the opportunities to support the vulnerable road users. Again, video analytics play a very important role in that. And then there were some work in real-time operation strategies for proactive safety intervention, including trip management strategies. For example, if you know that some routes are more dangerous in terms of recent crashes, especially if it's involving certain user groups and so on, then you might try to apply that in the management, in trip management strategies and rerouting and so on. Traffic signal strategies, there is an opportunity, let's say, about incorporating safety in the activation of timing plans or traffic strategies and looking beyond just operation. Some initial work in that, but we also follow up with some of the problem statement that we have here. And then some driver warning strategies as well that were mentioned in the literature. Next. There were some, are you going to talk about that, Filmon?
Yeah, I can quickly go over this.
Sure.
So to supplement the literature review, we also spoke with several state departments of transportation and also local agencies. I will quickly go over the findings of these interviews with these agencies. So first we spoke with the City of Bellevue. We have Daniel, who is from the City of Bellevue. He's going to talk more about this, but overall, what they are doing is they are using high definition camera and LiDAR to detect potential conflicts and avoid incidents involving vulnerable road users and also regular traffic. We also spoke with Arizona Department of Transportation. Arizona is implementing data-driven traffic safety strategies. Every year they go over their network and they pinpoint high-risk crash locations. And they do have a predictive model to predict anticipated crashes. And they are also experimenting with dynamic message signs to alert drivers of any hazardous conditions. They are implementing creative ways of advancing ramp metering in the Maricopa County to enhance flow and also safety. We also spoke with the Ohio Department of Transportation and Smart Columbus. They are implementing a number of innovative actions. For example, Ohio DOT it already has a variable speed limit that adjusts based on inclement weather conditions, especially up north in Ohio. It gets a lot of snow, so they have this weather responsive variable speed limit. Also, the Department of Transportation has a tool which they call a Traffic Operations Assessment Tool, or TOAST. The tool helps them to analyze congestion and identify bottlenecks, crash severity, reduction of certain improvements, and also the tool helps rank corridors based on safety and operations metrics. The department is also working with some crowdsourced data providers, and that helps them to enhance their incident management operations. Speaking of Smart Columbus is part of the Smart Cities Challenge or initiative, and they are using real-time data for signal priority and also for providing warning to other drivers of any vehicle that is that's running a red light. Florida, Florida DOT, they are using signal performance for safer intersections. They use automated traffic signal performance measures, that's the ATSPM. They have high resolution data, and that data is analyzed to identify any potential safety issues at certain intersections, and not only identify the issues, but also they go ahead and fix the issues based on these high resolution data. They also have some programs related to preventing crashes involving vulnerable road users. They have tested some strategies like leading pedestrian interval and protected permissive spacing. Also, they are working with other data providers in this area. We also spoke with Kentucky Transportation Cabinet. They are using crowdsourced data for real-time safety interventions. They really use the crowdsourced data in a creative manner, and that helps them to detect and verify incidents as early as possible. The crowdsourced data that they have is updated every 2 minutes, and any incident is quickly identified and is validated by feedback from road users. They say that the crowdsourced data has been very, very useful in areas where there is limited coverage by CCTV cameras. And also, they mentioned that this crowdsourced data was very helpful in the emergency response activities that they did due to the flooding in Eastern Kentucky that happened in early 2022. Indiana DOT is using connected vehicles data in work zones, and that helps them to identify special locations with high crash risks. They are specifically looking at the frequency of hard braking data. They have analyzed more than 200,000 hard braking events across 23 work zone locations, and based on this emerging data, they were able to identify some geometric improvements that could be done, that could be implemented to improve the infrastructure layout, and also they came up with a new layout of a taper section of work zones. And we also spoke with the Tennessee Highway Patrol. The agency is using a tool that is developed by in conjunction with Volpe, and they are using this tool to identify high-risk locations, not just identify them, but also they go ahead and use this tool to pre-position their incident response team and also optimize their patrol deployment. They use historical crash data, weather data, special event data in conjunction with crowdsourced data, and that helps them to optimally allocate their limited resources when it comes to law enforcement and also incident response team, so that they can quickly respond to predicted incidents and minimize any harm that results from crashes. The last the last implementation that we looked at is actually a data provider, and the General Motors, that's the vehicle manufacturer, GM, is putting together a lot of connected vehicle data from their 15 million plus vehicles that are out there in the road, and this data is helping agencies to plan safer roads. The Future Roads Initiative and the Safety View platform that GM is providing is putting together all the crash information and demographic information, as well as vehicle data to support data-driven safety planning across the nation. Several agencies have used the Future Roads Initiative and also the Safety View platforms, and they were able to identify and address safety issues in their road networks. And this has really been helpful in streamlining and prioritizing projects that directly address safety. So these are really good examples where emerging data sources, emerging technologies, and also creative operations strategies were used to improve safety throughout the nation. Monty, I'll let you take over from here.
Thank you, Filmon. So basically what we did is we started brainstorming and thinking about what we have read in the literature and what we have learned from the implementation and so on to come up with some ideas. Initially, we did 13. So produced 13 specific topics, and each of those topics fell into one of 5 different broad categorization, including advancing signalized intersection operation strategies, operations data analytics and surrogate safety measures, effectiveness of operation information sharing on driver safety, fleet operation and safety intervention, and then work zones and road-related interventions. We produced those 13 ideas, and then we ran them by the FHWA staff and some external review panel that we formed for the project. The review panel was multidisciplinary, and we asked each to rank those ideas for strengths and weaknesses so that we can pick 3. So we wanted to pick 3 at the end that we can expand into standardized research problem statement. Please, next slide. And so on the left, you have the category, one of the 5 that I just mentioned. And then on the right, you see the different ideas. So on the right, you have 13. Implementation of traffic signal control strategies to improve safety, safety measure for intersection using connected vehicle data, and so on. You see that the operation data analytics and surrogate safety measure is the one that had 5 ideas. So it was the one with more ideas and more opportunities for research advancement. And then the effectiveness of operation information sharing on driver safety had 3, followed by 2 for the first and fourth categorization, and only 1 on work zone intervention. I'll talk more about the ones that we ended up selecting after the next slide and expand on those, just for the sake of the time. So you see here each one of the research need statement on the left, and then on the right you have the roundtable ranking. This is from the panel, and then the FHWA ranking, and then we have a weighted ranking. So we have 60% assigned to the panel and 40% for the FHWA, and we sorted all of those research need statement based on that weighted ranking. So the one that came on top is assessing the reliability of hard braking and other vehicle-based metrics as surrogate safety measures, followed by implementation of traffic signal control strategies to improve safety, and then framework and tools using artificial intelligence, machine learning methods to identify operation strategies for proactive safety. When we discuss each one of those, like I said earlier, there were some work going on, but we focused on the opportunities for the biggest bang for the buck, basically looking at what really needs to be done different from what has been going on. So please go to the next slide, Filmon. And we wanted to put all of these top 3 into the standardized research need statement. from the TRB, because we want this to go for an NCHRB, hopefully, project at the end. The RNS structure, uh, go back a little, so includes a title, background, and scope, the objective, that's the highlight, and then the potential benefit and relationship to existing body of knowledge. And then alignment with the 2126 American Association of State Highway and Transportation Officials, strategic plan, what kind of task we envision that work need to include, and what the estimated funding would be, and scope and schedule, and then follow on and implementation activities. Please, next. So the first one was assessing the reliability of hard braking and other vehicle-based metrics as surrogate safety measures. There was some work already going on hard braking, and the idea is if you are getting all of these crowdsourcing data from the vehicle manufacturers, whether it's being resold through them or through other vendor, you can identify areas and times where there is a lot of hard braking happening. And that could be an indication of a safety problem going on in there. But then what we really wanted to look at is the validity of using that hard braking all by itself, or whether it need to be augmented by other things and have like more vigor into the way, excuse me, that this could be analyzed. So the objective is to analyze and validate hard braking and other vehicle-based metrics as reliable indicators of crash risk. The approach is to examine correlation between those metrics and actual crash data, and the goal is to determine applicability for proactive safety intervention that enhance both safety and mobility. Let's go to the next one. I want to talk about the tasks a little bit. So the tasks include assessing current research, review agency lessons from using trajectory data and surrogate measures, identify advances in safety metrics, behavior models, and crash prediction. So just to highlight the point here, the idea is not to just go with hard braking as the sole or the very reliable measure, but really looking into the behavioral model that we can bring into the table and the other safety metrics that could be brought into the table to make this more reliable. And then also looking at evaluating new surrogate measures and their use in decision support tools, and then define concept and scenarios for field test and simulation. And then the standard NCHRB format is to prepare an interim report before you move forward. So moving forward would be to develop the tools and run field tests to assess safety and operation impact. Next slide. The next one was the implementation of traffic signal control to improve safety. And again, the general idea is that we used to think in a compartmentalize when we look at traffic signals, that we design traffic signals timing plans to improve, to reduce delay or improve throughput. But what we wanted to do here is to look at the safety itself as an organic way of operating those traffic signals in addition to improving the operation. So, and we started first looking at adaptive control and then traffic responsive control. And then the idea was let's look at everything that has to do with traffic signals by looking at this new objective. So the objective here is to advance traffic signal control methods that integrates both safety and efficiency. The approach is to create safety indices and multimodal strategies for signalized intersections to reduce fatalities, serious injuries, while maintaining smooth traffic operation. And then the analysis, we anticipate that would include statistical analysis, but also modeling of control methods and optimization, of course. Multi-objective optimization in that sense. And then the anticipated outcomes is guidelines for novel traffic responsive and adaptive control method for safety improvement. Next. And then the task, again, all of them have the idea of you need to review and critique research, current research and past research before you can build on the new research that you want to do here. And also looking at the finding from agency-led studies on safety, so we can incorporate the advancement that they have especially with the case studies that we have talked about and the people that we discuss with. And then examining emerging multimodal signal control technologies. So we don't just want to look at vehicles, but also other modes of transport, and develop a concept of operation and scenarios for pilot studies. And then after the interim report, conduct safety and operation studies using both simulation and field data and any other validated method that could be brought up, whether from the field or different fields as well. Next slide. And then the third one was a framework and tools for using AI and machine learning methods to identify operation strategies for proactive safety. And again, we have seen a lot of AI methods being applied, a lot of machine learning methods being applied in the literature, but we are not talking here about using a specific method to improve the modeling accuracy, but rather having a whole framework that incorporate machine learning and artificial intelligence, but to not only predict what the data is telling us, but looking at if we proactively implement a certain strategy, what is going to happen and how things are going to shift in an overall transportation framework. So this is, if we look at the objective, it's developing a predictive machine learning framework to guide proactive safety intervention. And these are the keywords for this particular statement. Next slide. So again, after review and assessing machine learning research, looking and incorporating, evaluating agency findings, then identify advancement in machine learning in crash prediction, safety modeling, and interaction with the vulnerable road users, and then explore existing machine learning sensing and decision support tools and their potential safety impact across user groups, then develop a concept of operation and test scenarios for field studies, and then after the report, conduct the studies using simulation and field data to evaluate the ML impact on safety and operation performance. So again, I want to highlight that point because it's not just about predicting what is going to happen given the existing situation, but predicting what is going to happen after implementing certain strategies that the machine learning would suggest, and look at how the whole system is going to change based on that, and then deliver final documentation and practitioner guidance. Next slide, please.
All right. Thank you, Monty. Based on the literature review and also the interaction we had with the different departments of transportations and also local agencies and data providers, we came up with a list of opportunities and challenges to accelerate the proactive safety interventions. I will quickly first go over the opportunities. There are a lot of noteworthy practices that are out there showcasing the successful agency implementations. This provides a really good opportunity for other agencies to learn from these initiatives and tailor safety improvements to their local needs. The other one is the use of research-backed guidelines. There are quite a few, I would say a lot of documents now that talk about how these emerging data sets can be used to improve safety, and also how operations strategies can be creatively used to improve safety. There are some documents that are coming out from NCHRP and also FHWA and other reports that are backed by evidence and also provide scalable traffic safety solutions. There is obviously a need to adopt predictive analytics, like Monty was saying. We can't really do much if we are simply doing descriptive analytics, describing what's going on. But instead of simple description, we need to do more of predictive analysis. So that way we can pre-position ourselves and move forward from reactive strategies to proactive strategies. We have to innovatively use surrogate safety measures. That's also another opportunity. It really provides a useful way of identifying high-risk locations and identifying them before significant number of crashes occur. So this leads us to be more proactive than reactive. And of course, we need to provide data-driven insights for any decisions that we make. So these are a list of the opportunities that agencies have based on our research. The challenge, um, the first one has to do with data and privacy issues. All these emerging data sources, they do come with that issue. Privacy is always of a big concern when it comes to high resolution data. And data quality is another issue here. Data integration and standardization is also a concern related to this because these emerging data sources have to be combined with existing data sources, and that's the integration issue. And the way these data sources are coming, they're basically coming in different formats, but they need to be standardized so that the integration process with existing data sources and data platforms can be easily handled. The second one is legacy system integration. We have issues related with data silos and compatibility with existing tools and existing agency platforms, and also capability of the staff that the agencies have. So the solution is agencies need to plan upgrades. They have to train staff and also engage with stakeholders so that they learn about this emerging data sources and these new data sources. And the third one is uncertainty related to the effectiveness of these deployments. Many of the deployments are really at a pilot level. They are not large-scale deployments, and also there were not a lot of evaluations done. When we were speaking with all the agencies that we interviewed, when we were asking them if they are creative use of data and operations strategies, if they were evaluated, if they have done any before and after data, they were always not providing a positive response to that. So we need a very comprehensive evaluation methods, like before and after analysis. We need really concrete numbers when it comes to reduction in number of fatalities, in number of crashes, and things like that. And also the statistical significance of these safety improvements is also of great importance. Scalability issue, there is uncertainty when it comes to deploying these strategies at a larger scale and more complex environment. So we need to start small and eventually grow big, and demonstrate this creative and innovative use of data at a larger scale. And all these innovative data sources come at a cost. So there is a high deployment cost related to these implementations. So agencies need to carefully plan and align resources. A few of the lessons learned. The first one is obviously we need to strengthen coordination among agency departments or divisions. We have the planning division, we have the operations and the safety and so on. All these different divisions within the same agency need to talk to each other so that there is a seamless coordination and a seamless flow of information between them. Scaling up successful pilot demonstrations is also what's needed. Another one is enhancing collaboration between agency and key stakeholders. These key stakeholders include the technology developers, the data providers, and things like those. There is really limited communication of the stakeholders with the agencies that are going to ultimately implement the technology or use the data that they provide. And expanding access to CV data is critical. CV data is emerging data, but it is always available at a subscription fee. And that could be a barrier when it comes to smaller agencies that have really limited funding. So we need to provide an easy access of the emerging data source to the agencies that have limited limited funding. And we need to promote communication and awareness of the benefits that could be obtained from using these emerging data sources and operations data to enhance safety, especially learning from early adopters, from researchers and the national organizations like the NCHRP or TRB. This could be this can provide really good support and boost confidence for further adoption. And some of the additional resources that you could learn from when related to this use of emerging data sources and operations for traffic safety are here. These are an extension of the other sources that Joe mentioned earlier. They are all available online from FHWA Office of Operations, so you are welcome to go ahead and check them. The final report of this project is coming in a couple of months, and it will be available for the public, and you can also learn more by reading that final report. With that, I will stop here, and I'm going to hand over the presentation to Ryan. Ryan is going to talk about how Pennsylvania DOT is using operations data to improve safety. And followed by Ryan, Daniel is going to talk about how Bellevue is doing, how Bellevue is improving safety by using advanced analytics and LiDAR.